In this video, we'll learn how to solve equations that contain a lot of fractions by using a technique that helps us eliminate the fractions, called clearing them. Let's look at our first example. 1/2 x plus 3/4 equals 5/8 x minus 6. And we notice that if we were to work with fractions throughout this entire problem, we'd have to do a lot of work to get common denominators and then remember all of our rules with fractions. So we'll begin by doing what states up at the top. Step 1, clearing them by multiplying each term of the equation by the least common denominator. So what I know is that I can multiply the left side of the equation and the right side of the equation by some number, any number I want. And in this case, the least common denominator of 2 and 4 and 8 is 8. And so if I would multiply both sides of the equation by 8, that's actually going to eliminate all of my fractions. Let me show you. 8 times 1/2 x. Well, that's going to be 4x. But the way you can do that quickly in your head is divide 8 by 2 first and then multiply it by the 1. So 8 divided by 2 is 4 times 1 is 4x. And then I distribute the 8 to my second term. 8 divided by 4 is 2 times 3 would give me a 6. So that becomes plus 6. Now, I distribute the 8 to both terms on the right side of the equation. 8 divided by 8 will give me 1 times my numerator 5, so I get 5x. And then I still need to multiply negative 6. Even though it's not a fraction, each term has to get multiplied in order for the multiplication property of equality to be true. So I get minus 48. Now, I can just solve this equation like I would do any other multi-step equation. Simplify each side of the equation, and then try and isolate my variable. So let's do those steps now. I'll begin by combining my 4x and my 5x by subtracting 4x from the left side and 4x from the right side to get 6 equals 1x minus 48. Now we know that 1x is the same thing as x. So let's begin, let's next isolate that x by adding 48 to both sides of the equation. And so I get 1x, or just x, equals 54. And now I've found my solution. I'll put it in my set builder notation. 54 is my solution. And you notice that for the entire problem, I didn't have to deal with fractions since I eliminated them in this first initial step. Now, example 2 will do similarly, but we notice that this time we have 2/3 outside of the quantity x plus 7. So it's getting multiplied with both terms. My recommendation is to begin by, this could be done several different ways, but I'd begin by distributing the 2/3 to both terms. So I get 2/3 x plus 2/3 times 7 would be 14 over 3. And then I carry down the rest of my equation. Minus 1/6 equals 9. And now I can pick the least common denominator of all my denominators in this problem and multiply it by both sides to eliminate my fractions. In this case, my denominators are 3, 3, and 6. So 6 is my least common denominator, and that's what I'll distribute to each term. So let's do the same technique. 6 divided by 3 is 2, times the numerator 2 is 4. So I get 4x. 6 divided by 3 is 2, times 14 gives me 28. So I get plus 28. 6 divided by 6 is 1, times 1 gives me minus 1. And don't forget to multiply the other side of the equation, I get 54. Now let's simplify each side of the equation. I can combine like terms on the left side. So I get 4x plus 27 equals 54. And now I'm 2 steps away. I subtract 27 from each side. So 4x equals 27. And I divide by 4. So x equals, I'll do it over here, 27 over 4. And that's my solution, 27 over 4. And though our equation is still a fraction, you can see that we didn't have to work with fractions the entire time since we cleared them in the first step. Just take note, you can also do this by, you can also clear equations that contain decimals. And you would do this by multiplying each side of the equation by units of 10 or 100 or 1,000, depending on how many place values there are after the decimal point.